Welcome to part 4 of robotic arm manipulation with human experiences and reinforcement learning. In this video, we're going to go ahead and start building the controller class that will allow us to control the robot with a game controller. I mentioned this earlier in the series, but I'm using a Logitech gamepad F310. I imagine that any PlayStation style game controller should work, and I'm sure you could use an Xbox controller or something else, but you may have to map some of the keys differently. If you want to follow along exactly, I will link the controller that I bought in the video description. It was I think it's selling for about $17 right now on Best Buy, so it's not not super expensive. If you don't want to use this controller, then by all means use whatever you've got on hand. This was just the cheapest thing that was compatible with Linux and got me up and running. So with that, we're going to go ahead and create a controller.py, and in controller.py we are going to need just a couple of imports. So we're going to import numpy as np, and then we're actually going to import Pygame. Pygame out of the box was able to see and support a game controller, which was really cool. So we're going to say class controller, and we'll set our init method. I can get rid of that none. We don't need it. It just kind of auto-filled there. We're going to set, so one of the things that I noticed is I did not want to have to constantly toggle whether the gripper is open or closed. So I set a self.gripperClosed method or variable to none. Then we need to do pygame.init and pygame.joystick.init. And then we need to do self.joystick equals pygame.joystick.joystick. And in this case, joystick refers to the whole controller. And then we do self.joystick.init. All right, so now that we've got our joystick init, the main and the only function in this class is going to be getAction. So we're going to get action self. And this is actually fairly long and not the most elegant thing in the world, but it does work very well. So we have 9 action dimensions. So action equals np.zeros, 9. Gripper button pressed equals false. We're starting out that way. And then we're going to start with, and I'm going to comment each one because this is really useful in this particular class. So we're going to map left joystick to joint 1 and joint 2 angular velocity. So that's going to be action 0 equals self.joystick.getAxis 0, and that is going to be the left stick horizontal. Action 1 is self.joystick.getAxis 1, and that is going to be left stick vertical. And then in my case, there are several places where I'm going to multiply things by -1. The reason I'm doing this is, I'm pulling the joystick back or down. I expect the robot to go down, and out of the box it was going up. This is one of those places where I would encourage you to build it out as I've built it, get it working with your controller, and then feel free to tweak and rearrange these in a way that makes it easier for you to control the robot. You know, there's no right way to do these mappings. The right way is the way that lets you most easily control the robot to accomplish the task. So code along with me, but then go and tweak to make it easier for you. Action 1. So we're going to multiply both of those by -1. Here we're going to map right joystick to joints 3 and 4. And here we're going to say action 2 is equal to self joystick get axis 3. Action, let's see, then action 3 is equal to self.joystick.getAxis 2. And then we're going to do action 3 equals action 3 times -1. Okay. And then this is where we're going to get into buckets. So, or buttons, sorry. I don't know why I said buckets. Buttons. So we're going to say if self.joystick.getButton 0, action 4 equals -1. And I found it was helpful to just go ahead and print out some output here. So button 0 pressed. That way, as I was playing with the controller, I could start to, because I mean, obviously there is no button 0 on a controller. If I look at my control, this particular controller, I have an A, Y, B, X. You know, I've got my RB, RT at the top. I've got my, you know, it's your standard, again, it's a rip-off of your standard PlayStation controller. So, you know, it's not easy for me to figure out which things are mapped which places without just testing. So this was a whole lot of trial and error, and we're about to write a long string of elifs, so I apologize ahead of time for that. But it was the best way I could think of to do it. So we're going to say self.joystick.getButton2. And that's going to be action 4 equals 1. And you'll start to see you'll start to see a little bit of a flow here. You know, this one's action 4 to -1. This one is action 4 to 1. So those two buttons will basically counter each other on that particular joint, whatever it is. So then we're going to say print button 2 pressed elif self.joystick.getButton, nope, not getAxis, getButton 1. And then we're going to do gripper closed on this one, so self.gripperClosed equals true. And also self.gripper, or no, we'll just do gripper button pressed equals true. And then we'll print out button 1 pressed. All right, elif self.joystick.getButton. And this one is going to be 3. So that's going to be self.gripperClosed equals false. Self.gripperButton button pressed. It's not self, it's just gripper button pressed. Gripper button pressed equals true. So if you're wondering why we're setting both the state of the gripper and whether the button was pressed, what we're basically going to do is set this up so that after you open the gripper or close the gripper, it's always going to send a gripper signal as either open or closed. So the robot will intelligently keep the gripper closed or keep the gripper open but we don't want it to just constantly return a value. We want it to return a value if, or we don't want to, we want to return a value even if you haven't pressed it in this round. We only want to change it when the button's pressed. That's basically what we're doing. Okay, so elif self.joystick.getButton4. We're going to map action 5 to this and print button 4 pressed. Elif self.joystick.getButton5. And we're going to do action 5 equals -1 and print button 5 pressed. We're getting there. We're about 2/3 of the way through. So here we're going to do elif self.joystick.getButton6. And we'll do action 6 is equal to -1. Elif self.joystick.getButton7. So for 7, we're going to do, and I forgot to do my print here. Print button 6 pressed. I could probably do one print statement at the bottom, but I think it would be just as much code to, collect that. All right, get button 7. So we're setting cell action 6 is equal to 1 for get button 7. Elif self.joystick.getButton8. Action 7 equals 1 and print button 8 pressed. I need to do my print up here. Button 7 pressed. And finally, elif self.joystick.getButton9. We're going to say action 7 is equal to -1 and print button 9 pressed. All right, and then I was actually able to do everything I did without ever using actions, any actions higher than 7. So we're going to put a mask. And why are we doing this? So there's a certain amount of jitter that comes from the controller, where it'll just constantly record some low level of action from your joysticks. And I didn't want to collect that data. Like, I really don't want it to collect that I have a jittery controller. So what we're doing here is we're saying NP, so our mask is the absolute value of action greater than equal to 0.1, and then action equals action times mask, and action equals np.where action -0.0 0.0 action. And that is going to cut off all actions. That's basically going to zero it out if an action is not greater than 0.1. And then we actually want to return none if it's all zeros. So we're going to say if np.all action equals 0 and gripper button pressed equals false, then action equals none. Else, if gripper self.gripper closed is true, action 7 is equal to negative 1.0. Action 8 is equal to negative 1.0. Elif self.gripperClosed is false. Action 7 is equal to 1.0, and action 8 is equal to 1.0. And then finally, we will return action. All right, we have completed our controller Pi. We can come back over here to human control and actually start using it. So we're going to go ahead and initialize our controller. We're going to collect a couple of variables here. So starting memory, because we're interested in how much memory we've stored in a given run. Chances are you're not going to sit down in one session and record all the data you need. When I was doing this, I probably spent 3 hours recording data, 3 or 4. And I'd record some for 20 minutes, watch a YouTube video on the side and sit there and open the microwave with the robot arm, 100 times. So you want to get feedback on how much data you've collected, and you want to be able to sort of start from your last starting place. So I'm going to say starting memory size is memory.memctr. And then we'll give ourselves some output here. Starting memory size is starting memory size. Okay. We're going to say controller equals controller. Oh, hang on. We have not imported controller. So from controller import controller. Oh. Controller. Okay. And then we're basically just going to run through as if we were playing an episode. Actually, let's just run this real quick and make sure that we don't get any... Good. No errors from the controller. So we're going to say while true. So, continuous loop, break out when the human kills it. Episode steps equals 0. Done equals false. State info equals env.reset. And we're going to say while not done, and episode steps less than max episode steps. And then we're going to get some basic Pygame events. So we're going to say for event in Pygame.event.get if event.type is Pygame.quit. Oh, I want that to be all caps. My editor is trying to be too helpful, and that needs to be a double equals. And I think I need to import Pygame up here. That's what it's complaining about. All right, so I'm importing Pygame. So we're going to say for events Pygame, if event type equals Pygame.quit, then I'm going to say running equals false. Elif event.type equals Pygame.key down. So we're going to specifically look for control H, because control H gets rid of the overlay on top of the Mujoko simulator panel. So we basically want to let those things go through and render the environment. So if event.key is equal to Pygame.kh and Pygame.key.getMods and Pygame.kmod CTRL. Okay, and then if those things, then we're going to do an env.render. So go ahead and re-render the environment. And then otherwise, we're just going to go ahead and grab our action from controller.getAction. Then down here, we will also say action equals controller.getAction. If action, and this is where the logic that we did to return a none if there was no valid action comes in. So we're going to say if action is not none, then we're going to say next state reward done equals env.step action. We'll say mask equals 1 if episode steps equal max episode steps, else float not done. And this is very similar to what you would do in a training loop. So memory.store, in fact, that's almost exactly what I did, is copied over a training loop and then edited it for human data. Action reward, next state mask, and then get some output. I think you know by now that I like output in my programs. I like to know what's going on. Episode step, episode steps, reward, successfully added, and this is where I want to know, we've got memory.memCounter minus starting memory size. So basically I want to know that we've added, how many steps we've added to memory. So I want to say starting memory size, steps to memory. I know this line's getting a little long. We'll bump that down. So successfully added steps to memory, and we'll say total is memory.memCounter. So that'll give us some feedback as we go. And then I'll say state equals next state. Technically, we could just recycle the state variable, but this matches what we'll do in training loops later. We'll do episode steps plus equals 1. And then I find it useful to have a, let's go import time. So I'm going to say time.sleep 0.05. And then finally at the bottom, we're going to say memory, or actually not at the bottom. We're going to line that up inside this loop. So as soon as it's done, every single time, it's going to do save to CSV. We'll pass in a file name, and that will be checkpoints. Actually, let's just copy paste. I basically want it to be this, except save to CSV. And then finally, at the very end, we do an env.close when everything's over. All right, and now we get to fire this up and give it a shot. Oh, it failed immediately. Okay, let's see. It says Pygame has no event. So somewhere in here, I did pygame.env. Right here, pygame.even.get. That's correct. Pygame does not have an event. Okay, so it does this sometimes. Let's just kill that and restart. So I'm going to run this. All right. So first I'm going to hit Control H and supersize, and it looks weird until you hit the button the first time. It still didn't pick up my Control H. Yeah, we'll fix that in a minute. There we go. I had to hit it a couple more times. So my target, and I am controlling this 100% with the game controller at this point. So what I'm doing right now is the left joystick for me, and I'm going back and forth with it. If I pull back on the left joystick, it sort of lowers slowly. If I go forward, it's going to raise the arm that way. Right joystick, pushing up, pushing down, pushing to the right, pushing to the left. That is left and right on the right joystick for me. All right, left, so on PlayStation, I think it'd be L1 and L2 and then R1 and R2. On this thing, it's LB and LT and then RB and RT. So R1, the equivalent, is R1, R2, L RT or R2, and then the same button on the opposite side is going to give me that motion. And in fact, let me see if I can just pull up a Logitech Gamepad F310, and we can just look at this together, as I probably should have planned this part out better, but that's okay. We will get through. So as I'm doing this, that little green A button is my close. The yellow Y is my open. The B button over here is kind of a twist motion, and the blue X is the opposite of that twist motion. So I've got twist, twist. That front button is my pivot to the right. The front button over here is my pivot to the left. The rear button over here is my spin. The rear button over here is my spin the other way. And then again, I think you understood what I meant with the joysticks. So that's my left joystick, and that is my right joystick. So what are we actually doing here? So my task is microwave. So I'm going to go ahead and full screen this. And I am going to come over here and grab the microwave door. And I'm going to open it. Come on, microwave, you can do it. So basically you are, and you'll notice it reset. So what you should see is, you notice down here it says reward 1.0. So it's telling us that we got a reward of 1 because we successfully opened the microwave. And if we continue to open the microwave successfully, so I'm gonna just slowly pull it back. And if this is really hard for you, it's fine. Like it, you know, I got kind of good at it because I did it a whole bunch of times. So, you know, expect it to, you know, it's definitely not natural to look at a 9 degree of freedom robot arm and try to control it with your thumbs. So give yourself some time to get good at this. If you need to, you know, get some good runs in and wipe a couple of memory buffers, that's fine. You know, honestly, even bad runs are useful data for the agent. You can learn what not to do along with your positive successful runs. So, you know, I don't actually put a lot of effort into keeping fails out because the method I'm using makes the failures valuable too. You know, just like in real life. And you want to do this a lot. You want to store at least right around, I think the replay buffer size we set was a minimum 32,000 with a 64 batch size. And honestly, that's right around where you want to be. You want to be at or over that 32,000 mark for data. And you'll notice that having played with this for a little while, just a couple minutes here on video, I'm at 2021 steps. Now, if you kill this, it should have saved a buffer, and if I rerun it, it should say right here, starting memory size is 2020, and then you can go ahead and start collecting some data. So, yep, I'm going to encourage you to go do a bunch of that. If you want to get through to the point where we're using the data so that you can both sort of test it end to end before you put a bunch of time into opening microwaves with a robot arm, that is totally fine. We can start training with a lower number. It won't be very effective with a small number of training runs. So we're basically going to go all the way through the process with microwave. We're going to get 30,000 iterations with the microwave, train it on how to do that, and then we'll cycle back through and do the same thing with some of the other tasks, with turning the stove on, with opening cupboards, things like that. So yep, get this working. Take some time, play with the robot, open the microwave a whole bunch of times. You should see a human memory microwave.mpz over here in checkpoints when you're done. And yeah, in the next video, we will come back over and start actually programming the train sections and the agent that's going to do some of these things autonomously. So see you in the next video.